Let's go. Monster. Not sponsored. All right. Chat, if you're watching, I usually have music on. I usually get my Discord on, and then I join a server and then stream stream my screen so that people can see the math that we're studying. Okay. We're gonna study mathematical induction. Usually I mute, and so people just do their own thing. Or if anyone's watching. Chat is supposed to watch today. Okay. And usually I share it to Christine. Okay. It's fine. Yep. Yep. Okay, stream is on. Alrighty. Should be this one right there. Okay. Here you go. I think the shipment will come tomorrow, and that's when we'll have our HDMI capture card, and so it won't look like this, and I won't be using 4G. And so let's firstly get our Numbas lesson done. I'll start to mute after I do week 7. So it should close tomorrow at 2 p.m. Let's start. Like that, and tutorial sets close to propositions. And so we should get to finish mathematical induction today. And then right now they are doing stuff about logic and truth tables. More specifically, the end here. And so by the end of this Numbas lesson, we should finish up proof by contradiction, mathematical induction, and then we're good. Yep. The negation of a proposition not P is read as not P. And not P is true. So the statement about not P is true if and only if the original proposition is false, right? So if the proposition is something about P, and that something about P is false, that means the proposition means the negation is true. The conjunction of two propositions, P and Q, is read as P and Q. It is true if and only if both component propositions are true. So P true, Q true, then P and Q is true. If P is not true and Q is true, then I'm pretty sure not true. Yeah, pretty sure. I mean, this is the start of it. Here. Let's just take this side. True, true, true. Right? That should look like a... yeah, let's look right here. True, true, true. If it's true or false, false. False or true, false. False or false, false. Okay? Just cover this side. The disjunction of two propositions P or Q is read as P or Q and is false if and only if both propositions are false. What I mean by that is if I'm given P, Q, true, 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 false, false, true, and false, false, then it's only going to be false, right? So P or Q is only going to be false when both of it is false. Implication is this implies and is logically equivalent to the proposition not P or Q. Not P or Q. This is a P implies Q, so not P or Q. It is false if and only if P is true and Q is false. Let's see it. P, Q, and negation of P or Q. Right? True, 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 false, false, true, and false. So it says it is true, it is false if and only if P is true and Q is false. P is true and Q is false. So I'll do it in laser. So this is the only time when it's false. Okay, let's write that down. False. The rest is true. Because let's actually do P implies Q because it's a lot easier to see. I don't know why they would do the logical equivalent. What did they say here? It's the same as. But what I would just look at is if right, P implies Q, right? So if P is true and Q is true, then it doesn't matter. Q is true. If let's do it this way. If P, then Q. If not Q, then not P. Is that right? If not Q, then not P. Yeah. So if it's not Q, if Q is false here, then P is also false. And so the statement is true. If P, then Q is okay. This is if not P, sorry, so not P or Q. Maybe I have some gap in my knowledge with truth tables. False only if the first part is true and the second part is false. Let's do the doctor medicine. First one is took medicine, got better. That's good. Didn't take medicine, still got better. Didn't take medicine, didn't get better. Took medicine, didn't get better. I'm guessing. I'm gonna ask ChatGPT one more time after that. Make sure it's really in my head. Hey, for truth tables, for if-then statements, could you explain to me why, let's say, if I'm looking at P implies Q, that if P is false and Q is true, then P implies Q is still true. Does it just, like, if I take the analogy that P is taking medicine, right? So if I didn't take medicine, but I still got better, that means I still got better. So that means the statement is true? What does that mean? How about if P and Q are both false? Nope. Gotta wrap my head around it first. Okay, let's just continue. I can remember. Double implication. The proposition P, if and only if Q, is read as P if and only if Q, and is logical equivalent to the proposition P implies Q and Q implies P. It is true if and only if P and Q have the same value. Okay, cool. The proposition, I can't read that, is read as P soar. Exclusive or is a logical operator that is true if and only if exactly one of the operands is true but not both. It is false if both are true or both are false. Okay. P, not P. If P is false, then not P is true. If P is true and Q is true, then P and Q is true. If P is true and Q is false, then P and Q is false because we need both. We need both to be true. If, right, we need this to be true all the time, or both to be true. So if P is false and Q is true, then P and Q are false. P or Q, right? So either one is true or both is okay. So an inclusive or. So if P is true and Q is true, then P or Q is true. If P is true, then one of the two is true, one of the two is true, and it's only false when both of P and Q are false. Okay, let's do P implies Q. So if P is true and Q is true, then P does imply Q, right? If P is true, then Q is true. If P is true and Q is false, then P doesn't imply Q. And so P implies Q, the statement itself is false. If P is false and Q is true, then the statement P implies Q is actually true. Why? Because P implies Q, we can always rewrite as the negation or Q. So it's either not P or. So just think of this as P or Q. So if one of it is true, then the statement is true, right? So we're given if P is false and Q is true. So both of this is true. So this is true. And finally, if P is false and Q is false. We're trying to do P implies Q. I don't know this last one. Oh. I'm assuming because there's an or here, right? That if not P is false, then P is true. Oh no, that if P is false, then not P is true. And so for P, Q are false, this statement here is true. Oh, I get it now. Oh, holy. Okay, P implies Q. If P is true and Q is true, true. If P is false and Q is false, false. In between, if false and false, then true. If in between, it's false. So the exclusive OR is probably the only one that we might want to look at. Exclusive OR. I'm just not going to look at the top. Right? And I'm just going to think about this for a second. So the exclusive OR means it's one or the other. No, it's never same values. So if this is true and true, it's not. That's false. This is true, and this is false. Okay, that's fine. Okay, we're going to fill out the truth table. This is going to be fun. Numbas. Listen. There's something I do need to. Oh, yeah, I do know. So, if I'm given A and B, A double implication B, then it's A implies B and B implies A. That's one law. And second law is the normal one. If A implies B, that's also equivalent to the negation of A or okay. So the negation of P double implication, negation Q, we could turn this into that implies that and that implies that. And once again, we're going to put the double negation here, or Q, which cancels the P or Q, and not. So Q. Oh, my bad. Not Q. P or not Q. and Q or not P. Has that made it any bit better for us? If this is an and statement here, so I need this statement to be true and this statement to be true for P and Q. So true, 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 false, false, true, false, false. Okay, let's think about this for a second. If P is true, or not P is true, this part's true, but we need the final part. So is this part true as well? It says here Q is true, so this part here, Q is true, so this part has to be true. This part is true because P is true. And what is it? It says and Q is true or not P is true. And not P is true. So I think this is false. And so this is false. If P here, let's think about this. This part is true. Is not P true? No, P is true, so not P is false. Is Q true? No, Q is false. Definitely. Okay, if P is false, P is false here, it's fine. Is not Q true? Q is true, so this is false, actually. And so if that's false, then this is false. Okay, double false. Not P is true, so this part is true. And not Q is true, so this is true, so this is true. That's my guess. So we're doing true, false, false, true. Okay, that's good. I got that first section good. We're going to do P or not Q. We've done P or not Q. That's P, T, F, T. And now we're doing this bigger one. That's not cool. Can we see something? Okay, I see that this part here carries over. Oh, okay. This is the implication of what we've already found. Right? So this big number is both of this. Is T, T, F, T, and T, F, T. And because this is a if and only if statement, it's an and statement. It's basically saying, does this imply this, and does this imply this? So it's only good for true statements, right? So if this is true and this is true, that's fine. And this is true, true, that's fine. So I'm gonna guess it's like this. Okay, we're just going to let that FTFT. No, it's Okay, let's just do it. Now I'm lazy. I want to think about how I can look at this better. I mean, if this is true, okay, this whole statement is the same as, sorry, yeah, this double implies that, whereas it has to imply this one as well. It's okay. I feel like if we expanded it, it'd be pretty shit. Ooh, sorry. I'm seeing something here. There's the negation right here. It implies the negation of this. So we're actually comparing true, false, false, true to false, false, true, false. And the only time that I see that the double implication has its own value is here. So the rest needs to be false. I'm pretty sure that's how they wanted us to solve it. Yes. So using laws of double implication. Thank gosh. We are 1/10 of the way there. Once again, let's do question 2. When evaluating compound propositions that use more than 2 simple propositions, we must include more rows in our true. I want to do it. This doesn't matter. If I can do the truth table, I'm pretty happy. P, Q, R for P and P or not Q. Yes, let's do it like this. That. So T, 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 F, T, F, T, T, F, 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 and F, F, F. Basically just shifting. Okay, P or Q is true, so this is true. P or Q is true. This is true. This is true. This is true. Not Q. Okay, P is false, or not Q is true. This is wrong. This is false. False. Once again, not Q is true. 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 Okay, number 2. Q and R. So this is just both have to be true. So these are one of the easier ones, right? So we just find when Q is true and FR is true. So this step here, and then this step here. So it's true here and true here, and it's false everywhere else. And then this is the harder question about the negation of our stuff before, and so we can copy this over. Let's actually make it like this. So the negation of P or Q, F, 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 T, T, F. Double implication, Q and R. T, F, 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 T, F, F. And so, because it's a double implication, guess what? We're looking for when they are the same. So we're gonna get some false value, some true value, some true value, some true value, true value, false value, true value, and true value. Okay, let's fill this out. We have T is true, T is true, T is true. This is true. This is false. This is true. This is true. This is false. This is false. This is false. This is true. This is false. This is false. This is false. This is false. True. 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 False. True. True. Perfect. Familiar with is the inclusion-exclusion principle. It relates the cardinality of two sets with cardinalities of intersections of both sets. Okay, so we're moving on to counting problems. We've basically finished logic and truth tables. A counting technique that we are going with from topic 1 is the inclusion-exclusion principle. I see this in the exam a lot. It relates the cardinality of two union sets with the cardinalities of intersections of those sets. In general, the size of the set is found by adding together the size of each set and subtracting the size of every twofold intersection, then adding back the size of every threefold intersection. Yes. 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 Add minus add. In a particular year, so now we are studying combinatorics. Well, everyone's pretty sick. Maloo, Wallamaloo, Wallamaloo, Walumaloo. Yes, this is a good place for inclusion-exclusion practice. So, inclusion-exclusion. Boom. 429 students study discrete mathematics, 382 study computing, and 221 study both discrete and computing. So this is something with 2 sets, right? And let set A be discrete math kids. B is comp 1A kids. And A intersection B maths. And so how many students study discrete maths or computing? So we see it's a yes or no thing. It's like, do you study math? Do you study math? Yes, no. Do you study computing? Yes, no. Do you study both discrete math? Union B. A plus B minus A intersection. These are the easier ones, but it's 429 plus 382 minus 221. And so if we think about it, we're double counting, and then we're just minusing one count. How much is that? We're going to put 1. Then we're going to put 70. 811 minus 221. We're going to put subtract 21 from here. Now let's do 611 minus 21 minus 11 minus 10 9. Please. Oh yeah. Okay. In a particular year. Jesus Christ. Okay. The inclusion exclusion principle that there are studying at least one of these 3 subjects have the right. Let's check. Okay. It wants us to show so at least 1. The term itself means A or B or C, right? So by inclusion, exclusion formula, 3, 4, 6 plus 4, 6, 9 plus 425 minus the intersection minus the intersection minus the intersection plus the final. Okay, I can't compute this in my head, so we're decimals. 3, 4, 6 add 4, 6, 9 add 4, 2, 5 minus 2, 3, 7 minus 2, 3, 8 minus 2, 3, 9 plus 1, 4. 640 students. Because checking the values in a different the university studying only fuck. You see something here? Or I have to draw it. $239 comp physics. Physics math. 238. Discrete math computing 237. 346. It looks like math is getting too low of an answer. Ooh, what happened? I haven't counted yet. 429 math. Study discrete will copy. Okay, let me do this again. Sorry, I'm calculating on the side. That's fine. But yeah, this is just all inputs. Six, 9, 1. Complement law, sorry. What is this? If an event can have n possible outcomes, and a particular event can occur in k ways, then the number of ways that the event cannot occur is n minus k. Sure. If there are n mutually exclusive events, if n mutually exclusive events can occur in k1 to kn different ways, then the number of ways one of the events can occur is k1 plus k2 up to plus all the way up to kn. If n independent events can occur in k1, k2, kn, then the number of ways every event multiplying. Sure. The string of digits is any sequence of digits 0 to 9 in any order. So, two main questions that professor always says. Is order important? Is repetition important? And yes, there's a table to learn. And it's better that we understand, but also good that we learn. So rep, good. Rep, don't need it. Order, good. And order, don't need it. If order matters and repetitions saying and stuff. But it's good that we fight at it. So you see, so 7-digit strings. Let's actually try to do it just thinking about it. Like, it's so weird to say, but right? So there's 7-digit strings where order matters, but repetitions don't, are okay. I'm pretty sure he did this in class. And it's like the Malu one. Wait, so if order matters, I'm guessing you can, like, you kind of have to go down, right? Right, so like you have to choose first digit, and there are 9 ways to do that. Let's just read on it. Unordered selections without repetition. So that's not what we want. We want ordered with repetition. That's also not what we want. We want ordered with repetition. Here, suppose that we have n different items and we wish to make our selections from these items. So the same selection may be selected more than once, right? And the order is significant. We're at the right spot. Then the number of possible choices is n to the r. So we could do we do 7 to the 9. Oh, sorry, 9 to the 7. No. We have n different items. We have 10. Yeah, we have 10 different items. 10 to the 7. Which means how do we write that? Would it just be make choice? like choose first digit 10 ways. Choose second digit 10 ways. Choose Arth. Choose Arth digit. Let's just do it n ways. So get n to the r ways. How many 7-digit strings start with 000 111 222? So I think we could do inclusion and exclusion. Pretty sure. Intuitively. Yeah, intuitively inclusion and exclusion. So we have what? 10? 7-digit string. 10 elements to choose. We've got order is important. Repetitions are allowed. And now the question is, how many start with either 0, 0, 1, or 1, 1, 1, or 2, 2, 2, right? And so we know the total, the universal is 10 to the 7. So that's from 0, 0, 0, 0, 0, 0, 0, 0, all the way up to a lot of numbers and 9, 9, 9, 9, 9, 9. Một, hai, ba, bốn, năm, sáu, bảy, tám. 7, 2, 3, 4, 5, 6, 7. Okay. So let A be a number. Starting with 0, 0, 0. And so that'd be strings start with 0, 0. Give me inclusion, exclusion. Here, this one. 25 to the 10th. 10-letter words with no Z. So would we have seven-digit string with 0, 0, 0. B, C, same. So do I assume that Do I assume that 0, 0, 0 is 3 to the 7 plus 3 to the 7 plus 3 to the 7? And we could do set. So we could do A and B, B and C, and A and C, because we have 7. And we could do 2 sets. Look at the coefficients. actually don't know. How many? Oh, this is sick. 97-digit step 1. So 7 digits. We make the choice of 000 for first 3. I actually don't know. Okay, total is this. So we can pick 10 elements 7 times. If we take away, then we can take 9 elements 4 times. Where did this question come from? That's kind of to choose, you have to do C7, choose 1. Here, imagine we have the 4 available element. No. So order is important. Rep isn't. Right? Order is important. And repetition. Order is important and rep is allowed. Order is relevant, and yes, so we've done that. If we have 3, so this right here is 4 to the 4 multiplied by 10 to the 4 digit. What if, bro? Oh my god. There are several cases to consider when the string starts with 0, when the string starts with 1, and the string starts with 2. When counting all these cases together, the value should be added. Are you seeing? It's 3 times. Sorry, it's added. How many 7-digit strings have a first digit, which which is even, a second digit, which is odd, and no digits greater than 8. Okay, 4. Repetitions allowed. Order important. Keep in mind that we're doing how many 7-digit strings have a first digit, which is even, any second digit, which is odd, and no digits greater than 8. So we're gonna choose the first one as an even, right? So chances, if it's 0 to 9, we have 0 is even, 2 is even, 0, 2, 4, 6, 8. So 5 even. So the first one is, I choose 5. 5 ways to choose an even number. The second digit is an odd number, so I also have 5 ways to choose the odd number. And then no digits, so the rest. Right, so third onwards to n. How many ways do we have to choose? We don't take 9. So we have 9 ways. 9 ways. So it's 5 to the second times 9 to the 5th. 3, 4, 5, 6, 7, 8. Sorry, 7. 9 squared times 8. None of the digits are greater than 8. So actually, this is wrong. This is 4 ways. So it's 5 times 4 times 9 ways. How many 7-digit strings contain at most 1 4? At most 1 4. And end in square number. So the square number in our set is a square number like 9, 8, 4, 1. 0? Is 0 considered a square number? Yes. 0, 1, 4. Is 8 is not a square number. It's a cube number. I'm a dumbass. Okay. How many 7-digit strings contain at most 1 4 and n in a digit that is a square number? So end. So order is important. and repetitions still allowed. But now it's just I have to for a first digit. Order matters, and repetition is allowed with the caveat of, okay, I mean, if it's 4, it has to be one of this. And then there's a chance where if this is 4 in here, then it's fine as well. Choose. Choose 4. Choose the 5 other digits. There are only 8 possibilities. Last digit has to be 3 ways. Or plus. Choose 6 digits, 8 ways. Choose last digit, 4. So this is okay, never mind. There's a plus. So this is 4 in the first few, 4 in last, no 4. Choose first 6 digits, 8 ways, 9 ways. Choose the first 6 digit 9 ways. Choose last digit 3 ways. So this is one way. 5 to the and 3 plus 9 to the 6 plus times 1 is 5 plus 9 to the 6 times 3. Yeah. Let's try it. How many 7-digit strings contain at most 4 and n an 8-digit number. First, consider the case where the string does not contain 4. How many options are there for the last digit? 3. In the case where the string does not contain 4, the option is there for any digit that is not the last digit. Nine. Next, consider the case where 4 occurs once as the last digit in the string. How many options are there for the last digit? 1. In the case where 4 occurs once in the last digit in the string, how many options are there for the any digit that is not the last digit? There are 9. Finally, consider a case where 4 occurs once in the string but not in the last digit. How many options are there for the last digit? 3. In the case where 4 occurs once in a string but not in the last digit, how many options are there for any digit that is the last digit? Oh, is that word? Did I do 9 to the 5? I did do 9 to the 5. Four occurs in the string but not as the last digit. How many pulses are there for? There are 6. Okay, this might be the step. Choose 4. At most a 4 at the end of the digits. Let's break it down again. 7 digits. 10 numbers. And we want to, at most, 1 4. And n in that is. So there's a case where no fours. Choose first digit 9 ways up to 6 digit. The end is choose 7th digit 3 ways. 1 4. And this is 1 4. 1 4 as in digits. So choose one thing 10 ways and choose the other 9. Ways. Choose 3 ways. And 1 4. Order does matter. Order matters. Reps doesn't. In final digit. Choose from first, 6th, ways. Choose last 4 ways. So this is 9 to the 6 times 3 plus 10 times 9 to the 5 times 3 plus 9 to the 6 times 4. Hey ChatGPT, my question is, I'm trying to find how many 7-digit strings contain at most 1 4 and end in a digit that is a square number. And the main question is that we have a string of digits from 0 to 9. And a string may start with 0, so repetitions are okay, and order does matter. Okay, so we've got so do we get our first one? 9 to the 6th. Yep. Exactly 1 4. Last digit is fixed and first digit is 9 to the 6th. So would it have been like this? Just one way. One way. Six choices, three choices, choices. Choose position of 4. Choose position. That might be the hard part. Choose position of 4. Choose position of 4. 6 ways. Choose digits for other 5. 9 ways. Choose last digit. 3 ways. 6 times 9 to the 5th times 3 plus 9 to 6 plus 9 to 6 of 3. This is the part that was bugging me. This I do want to try this question again. I know I can pretty sure I can review it like this. Yeah. There are the number of ways to arrange the letters of word with distinct letters is n factorial is equal to 1 up to n by convention where 0 factorial is 1. More generally, suppose a word of length n is made up of letters from the set LLM with k1 instances of letter 1 and k2 instances of 2. And the number of ways to arrange the letters in a word is n factorial times different arrangements. So arrangements for A, B, C, D, E, F, G. I don't think we do P choose, right? Right. So reps are repetitions not allowed, and order matters. but it says here words, so repetitions allowed. And order matters. How many arrangements are there for the word A, B, C, D, E, F, G? Seven factorial over 7 factorial ways. How many arrangements of word contain the subword A, B, D? So we want to group this. This is the Waterloo. So we have A, B, C, D, E, F, G. And we want to group these guys into A, B, D, C, E, F, G. So this is one word. And I can put this word anywhere. Right? P7, choose 3. Yo, this is a complete guess, by the way. Repetitions are allowed. Repetitions are allowed, and order is not relevant. M plus R minus 1 and N minus 1. So yeah. Unordered with repetition, right? like A, B, D, A works. I can't group it. Here. To divide the amount of times, or they not? Is it? Okay, let's think about this way. We have to put A, B, D somewhere. I can put it the first, the second, the third, the fourth, or the fifth. So there's 5 places I can put it. And I have to put the other words around it. Does that work? Hey, how do I find how many arrangements of a word contain a certain subword? To count arrangements containing a given subword, treat each subword as a single block, then rearrange. If the arrangement has n letters, the block reduces to n minus r plus 1. Treat that as r. If repetitions exist, by the factorial subgroup. So how many times can I do A, B, D, C? But I could do it again. But what if I could have like more A's, more B's, and more C's? So when you set the n minus r plus 1, why is that? Like that. And minus 1. Choose from set of new elements. And subtract 1. This is when repetitions are not allowed. Sorry, order is irrelevant, but repetitions are allowed. So right here. I wish. How many arrangements are there of the word A A B B B C C C D D? Sorry, D. 2, 3, 4, 5, 6, 7, 8, 9. And because there are, this is the Wallamalu method. Pretty sure. Right, so order matters, right, for Wallamalu. Permutations with, this is 9 factorial divided by 2 divided by 3 divided by 3. So it's not too much. How many arrangements of the word containing subword AAB? So we're doing a block, right? So we have AABBB, CCCD, and that's 9 factorial over 2 factorial over 3 factorial over 3 factorial ways to arrange. And then we have subword, which is C, choose. N minus R plus 1. N minus 1. How many arrangements of that contain that? We have that. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 elements. Trying to do AAB. Minus 3 plus 1, 8. C, 7, choose 8, 0. What? Why the fuck did I do 5 factorial? If I split it, that's 1, 2, 3, 4, 5, 6, 7, 7. Don't even. Place it in set. Nope. Subwords. How many arrangements of the word AAB contain these subwords? That factorial times 5 factorial. Don't even kill me. I'm actually pretty clueless. How many arrangements of the word AA, BBB, CCC, D contains the subword AAB? Why couldn't I just like shift it to the right? So if I had like a a B at the first, and then AAB, and then continue on, and then just like shift it. So like 9 ways I can put AAB within the 9 block. Okay, 100 permutations. I'm assuming you treat AAB as a block. So AAB is itself, and there are 2 B's and 3 C's. And so there's 7 total, right? So AAB is 1, B is 2, B is 3, C is 4, C is 5, C is 6, and D is 7. And then you divide out the thing in that form. That's the total arrangement for that specific number. Okay. Wait, that's it. How many arrangements of the word AABB contain the word BAC? I'm guessing the same same idea. Would I treat BAC as a word, and then there's 1 A, there's 2 B's, there's 2 C's, and there's 2 D's. So there's 1 term, 2, 3, 4, 5, 6, 7 terms over 2 factorial, 2 factorial. Why? Not repeatable. Repetitions are allowed in order is important. Repetitions allowed. Order is important. And are. Fuck. BA could twice in arrangement. Okay. Oh, okay. Would be more. Holy shit. and you go through the different ideas and different types of questions that are being asked. So I'm guessing if we use this term, we're gonna get counting that twice. Oh, okay. And we do BAC, and we get 1B left over, 1C left over, 1D left over. 5 factorial. Fuck. Would it be B? So there's 2 of BAC, right? Yeah. BCT. And so this is 2 repetitions of this. So there are 5 factorial ways divided by 2 factorial ways. So we want to minus. I should just write that. Sorry, guys. These questions are so tough. Slippery fingers. Jesus Christ. Mad tough. Suppose we have a hypothetical new alphabet with 14 letters partitioned into 9 consonants and 5 vowels. Letters. 9 consonants. 5 vowels. How many different 5-letter words can be made with this alphabet? 14 to the 5th for now, right? Choose 14 ways. 5. Fill out the following table. Number of 5-letter words with exactly n vowels. Does order matter? Order matters, but reps don't. Order matters, but reps don't. Right? Number of 5-letter with exactly n vowels. So choose 5 times 9 ways. So that's consonants. 9 to the 5th. Right? N is 1. Choose 1. Choose 1n. Choose n 5 ways. And choose digits. 1. So that's 5. Choose other 4. 9. So 4, 5 times 9 to the 4. There's 5 n's that we can make, right? Way. Yeah. Okay. I have to choose n. I have to choose where to place the digits. Right? So place to put digit. Okay, and 9 to the 4 is the rest. If n is equal to 2, choose n 5 ways. Place to put digit is 5 ways. To put it, reps matter. No, it doesn't matter. Order doesn't. So this one. C plus F. C plus N minus R. Actually, don't know this part. And fuck. If a little word has actually one vowel and they create self-forms, of which how many such forms are there altogether? 5. What's this? Wait. Hey, in C and R, it always adds up, right? Like n factorial over r factorial multiplied by n minus r factorial. So there's always going to be a difference, and that's going to add up to n factorial. Fuck them. But it's basically right. Repetitions do matter? No, it doesn't matter. And order doesn't matter. Fuck, man. They're moving so fast. What does a P and R look like? N over n minus r factorial. Okay. Order matters. Order matters. Order doesn't matter. 5 factorial over Thank you. Now I can see it. Yes, so this number is 5 factorial over 2 factorial, 3 factorial. Then, if we've chosen 2, then there's still C3 choose. So, times I'm going to choose the type of vowel, right? Jesus. Three choose. Sorry, 9 choose 3. 5 times 5 times 9 factorial over 6 factorial, 3 factorial. Okay, got this. Hey, I'm given 14 letters of a vocabulary, and order doesn't matter, repetitions are okay, and I want to find a 5-letter word that has exactly 2 vowels. So what I did set up there is I know that there are 5 choices of vowels, right? So So maybe I don't need to do the 5 at the start. But it's it's 5 choose 2 times 9 choose 3. Hey, we're supposed to be doing combinatorics. Oh, he is writing combinatorics. Fuck me. 6 choose 2. Wow, combinatorics are not fun. Order is irrelevant. Yes, repetitions are allowed. Fuck, once again, it's this. C N plus R minus 1 and minus 1. Can I reread the question? Did I get that? Cruise with combinatorics. Jeez, bro. Jeez, bro. Once again, exactly 2 vowels. 9 consonants. Order doesn't matter. Reps count. N, C. R is a group of I don't even fucking get it anymore. 2. "19 consonants. Sorry, 9 consonants. 4 vowels. 2 groups of vowels. 2 vowels. Exactly. Order doesn't matter. So R is 2. C 5 plus 2 minus 1. N is 5. Here's where I don't get the fuck. What the I'm gonna need the full explanation here. Unordered repetition is what they call it. Stars and bars. Why is it not n minus 1? Where n that isn't that when it's 4? Oh, so I could have R dots. Is that where the formula comes in? What did you take in, brother? Two vowels. 3 consonants. Out of 5 vowels. And 9 consonants. Order doesn't matter. And reps count are relevant. Okay. Two vowels, 3 consonants. Order doesn't matter. Reps are allowed. Fuck! I also have to do this. Wow. There's a lot that I'm not familiar with. I need to get familiar with. Just think of it like that. I have no fucking clue. Multiply by 9 consonant. There's 3. 9 minus 1. That's 8. Choose 8 is basically impossible. I'm trying to choose 3. Do we choose 3 there? 5, 11, choose 3. Someday I will understand. But this is this multiplied by this. I hope that's right. Honestly, don't know. Oh, it doesn't matter. It legit doesn't matter at all. choose 5, choose 2. Sorry. Times C. 9, choose 3. Let's see if that works. It's 2:37. I had my fair share of locking in today. Maybe I'll get it tomorrow. No way. Here, 5 choose 1 times 5 times 9, so 4. Could I have thought about it like that? 2 vowels. Choose 2 vowels. 5 ways. Right? I'm guessing that's C5, choose 2. Then place vowels in 2 places. 5 ways. Place consonants 3 places. 9 ways. Mother. Sorry, 5 factorial over 2 factorial times 3 factorial times 5 squared times 9 to the 3. Okay. 5, same. There's 3 places and 2 places I can put it. 5, 4 factorial. And there's 4 places I can put it. And finally, 5 to the 5th ways over 5 factorial to 5, which is 1 factorial. So there's 5 to the 5th ways to do it. Whatever, bro. How many 5-letter words have at least 1 consonant? So this is inclusion for sure. least one consonant. So either find set without consonant. That without consonant. Choose. Oh, which is this? Right? Yeah, it's all 5 vowels. So the maximum is that. That took me 3 hours. But I've now gotten it and 9.5. So 15 plus 9.5 is 20.5. My assignment hopefully gets 10. Sorry, 15. So that would bring me from a 24.5 to a 29.30. I just hope I get it. That was a hard question. I am tired. Good night, guys.